Hi student, today I am going to teach you the operation of BJT transistor. As we know, in BJT there are two types, NPN and PNP transistor, but how it works after applying the external DC supply to the both junction, that is emitter to base and collector to base junction, that we are going to study today. But before that, we need to know that how it works in an unbiased condition. That means if we are not applying any voltage across emitter to base and base to collector junction, what is the depletion region at both the junctions and how the majority carriers are there in this unbiased condition of transistor, we'll see here in this diagram. As we know, it is in unbiased condition, so we have not applied any voltage across these two junctions and also from collector to base junctions. So you can see the majority carriers. Now this is what the NPN transistor, right? That means P-type layer is sandwiched between two N-type layers. So the majority carriers in N-type are the electrons, which I have shown here in both N layers, and at the middle there is a P layer where I have shown the holes, and in between emitter to base junction here from you can see depletion region at JE. So this is the depletion region width at emitter junction, we can call it as a JE. Similarly, depletion region at collector to base junction is called as a JC. It means collector junction. But if you compare depletion region at both junctions are similar. Why? Because this is unbiased condition. So that means there is no electron and hole movement inside this NPN. So there, as we know, there are three terminals: emitter, base, and collector. So at two N-type layers, there is a emitter and collector connected terminals or leads connected respectively, and base is the middle terminal or the lead which is connected to the P layer. So you can see one more part, important part here, that is the penetration. So as we have already studied in the theory lecture, as there are two types of priorities, doping wise priority and the region or the area which is allocated to that particular region is base is having very less area, base is having very less area than emitter but if you compare a region area to all three layers, collector is having high or you can say large area, right? So area wise, the first priority collector, then emitter, and then base. Another priority is there, that is a doping priority. So we know that base area is very lightly doped area or thin area here. Here you can see base is lightly doped area, collector is highly doped area. But if you compare collector with emitter, doping level in collector is little bit less than emitter. So you can say emitter is having highly doped area than collector, and collector is again highly doped area than base. So the junction or the penetration towards base, if you study emitter to base junction only, if you focus on the junction only, penetration towards base is always high. Why? Because it is lightly doped area. So I have shown two columns with the holes here, and only one column is here, you can see, which is towards emitter. So that means here you can see emitter area starts from this point to this point, right? Whereas base area starts from this point to this point. So this happened at the emitter to base junction. But if you check again collector to base junction, same case you will observe. Why? Because if you compare the doping level in collector and base is what? Lightly doped area. So penetration towards the base is high comparative to the collector. So these are the 2 points which we have to focus in an unbiased condition, and how it is changed in a biased condition that we will study now. So this is case in unbiased condition. Now we'll move to the biased condition. How how it how the movement of electron and hole is there, that we will study. So here NPN transistor, same transistor we have used with the two resistors. So here you can see the role of resistor is what, for only current limiting purpose. Now as we know, when emitter base junction is forward bias and collector base junction is in reverse bias, that time this transistor BJT is works in an active region. So as we have discussed these three regions in the theory lecture, that is, it is having three regions: active, saturation and cutoff. And by applying different biasing conditions across these two junctions, how it works in a different regions, right? So whenever we are applying emitter base junction to the forward bias condition and collector to base junction is in reverse bias condition, that time this transistor will work in a active region. Similarly, now you focus on depletion region at JE and depletion region at JC. There is a lot of difference. Reason is what? The forward bias junction and reverse bias junction. So when N region is connected to the negative polarity of the DC external battery and P region is connected to the positive polarity of the battery, then this junction will work in a forward bias. Similarly, when N region is connected to the positive polarity and P region is connected to the negative polarity of the battery, that time this work in a reverse bias junction. Now you can see the depletion region at JE, it is very much less as compared to the JC. So here you can see how the electron and hole movement is there. So as we have studied in biased condition, there is a majority carriers in N region are electrons. Now when you are biasing JE junction, it starts moving. So very few number of electrons will recombine with the holes in P region, and remaining large number of electrons will combine with the holes in collector region. Why? Because base is lightly doped area and collector is highly doped area. But if you'll see the polarity of the battery, that electron which I have shown to the right hand side of this region attract towards the positive terminal of the battery, whereas holes will attract towards the negative polarity of the battery. So JE formed here, depletion region formed here, but large number of electrons will cross the base junction and it recombine with the holes which are present in the collector. So here you can see that the left hand side I have shown electrons which are at the left hand side and holes at the right hand side. Why? Because this is in reverse bias junction. So the potential across this region, it is called depletion region, is called barrier voltage. So barrier voltage can observe at JE and JC. So JE is having very less barrier voltage and JC is having very large barrier voltage. So when we apply the voltage across JE and JC, so when that time this transistor will work in active region. So when we apply such kind of biasing conditions, in this way the barrier voltage is generated due to the depletion region. But where it is high, where it is low, it is depend on the doping area. Thank you.